Myself, Ramesh Kumar Ponnada. Now, I would like to introduce one of the great subject from our graduation, that is none other than what? Control systems, right? So, before going to discussing about brief analysis related to control system, now I would like to ask one straightforward question. The question is, what is the need to learn? If you want to study whatever the subject, have some backup or not, have some practical cases or not. So for that purpose, we need to learn about what theoretical approachment or not. Like that, what is the need to learn about the control system and what is the relevant practical cases for what control systems? That is my question. So it's very clear. For example, consider whatever the practical device right now, like washing machines, otherwise like what air conditioners, otherwise like what iron box, otherwise like what fan, whatever it is, all the practical devices nowadays working with what? Either sensor, otherwise like what controller. That means what regulators and remote, those are like what controllers, and sensor is like what feedback element. Why this is act as a feedback element, I would like to introduce clearly. Wait some time, have some clarity or not. So whatever it is, nowadays what we are learning, all the practical systems, so those are like what relevant to where it is controllers, otherwise like what sensors, right? So those are initiated from where it is this subject, right? So that is the need to what? Learn about this subject. Are you clear? So this is very, very important subject, at the same time very easiest subject. Are you clear? Right. So before going to start this subject, first I would like to discuss what are the reference textbooks are required for this case. Reference textbooks. Right. So, according to my view, 5 best authors are there. I would like to introduce that authors right now. Are you clear? So, first one is Complete Control Systems by author name is Ogata. O-Z-O-A-T-A. Are you clear? So, Complete Control Systems by author name is Ogata. And the second best book is Control Systems by B.C. Koo. Benjamin's C. Koo. Right? B.C. Koo means Benjamin's C. Koo. And third one is again Control Systems by Nagarath and Gopal. Nagarath and Gopal. Right? Next, Control Systems by Nagur Kani. Author name is Nagur Kani. Next, Control Systems by author name is Jerath. Author name is Jerath. Are you clear? So 5 best authors. So check once. First one is Complete Control Systems by author name is Ogata. What is the meaning of complete control systems? See once. We have a lot of types of control systems. Ideal control system, practical control system, static control system, dynamic control system, base control system, automatic control system, manual control systems. You have some clarity or not? Like we have like different categories of control systems. For complete control system analysis, the best book is like what? Ogata. Are you clear? Like this, these are the best 5 authors, right? So these are the reference textbooks, right? And before going to discussing about my brief analysis of control systems, first, what type of the competitive exams are preferred this subject? First I would like to discuss. Are you clear? So according to our BTech graduation, we have 4 best category of exams. What are the 4 best category of exams? First one is GATE. Second one is Engineering Services exam. That means what? IES. And third one is non-through GATE exams. Non-through GATE exams. So what are the non-through GATE exams? I would like to explain just a couple of minutes. Next, state-wise exams. State-wise exams. Are you clear? So I hope you know it. So what are the companies are recruited through GATE. For example, we have basically three category of companies: Maharatna company and Navaratna companies and Mini Ratna companies. Are you clear? For example, IOCL and BHEL. Like that, some companies are what under Maharatna. And next one is Bell, Bharat Electronics Limited, and Vizag Steel Plant. So that's this type of categories under varieties Navaratna. BSNL JTO, Airport Authorities of India. These are under varieties Mini Ratna. Have some clarity or not? These are three different categories. So check once. Nowadays, all these three category of companies are recruited through varieties GATE. Are you clear? Not only that types of companies, even though DRDO and sometimes ISRO also recruited through varieties GATE score. And not only that case, for if you want to go to like what PG level, otherwise like what if you want to go to like what PhD, whatever it is, need what GATE score. So that is the importance of the GATE. And next one is engineering services exam. I think you know it. What is the importance of the engineering services exam? Next one is non through GATE exams. What are the non through GATE exams? So see, previously I discussed what some few companies like cadre companies like what Maharatna, Navaratna and Mini Ratna, right? On that, some companies are not recruited through GATE. So those are conducted like what separate exam. For example, PGCIL, Power Grid Corporation of India Limited, through GATE is there, non-through GATE is there. For example, Bell, Bharat Electronics Limited. So it is not recruited through GATE. It is conducting like what separate exam or not. So those are like what non-through GATE exams. And state-wise exams, for example, Transco and Genco and like some departments categories is like what state-wise competitive exams. So check once, whatever the competitive exams, control system is play the key role. Are you clear? And control system is a common subject for what? Three different branches. What are the three different branches? Those are ECE, Electronics and Communication Engineers, Electrical Peoples, EE, and next one is Instrumentation. It's a common subject for communications, communication engineering, and communication means what? Communication engineering, telecommunication engineering, all category of communication engineering. Next, electrical engineering and instrumentation engineering. It's a common subject. Are you clear? And see, go to any competitive exam. See, this control system is play the key role and is contains like what more score. Are you clear? So what is that weightage? Now I would like to discuss like what sector, that means what competitive exam wise, right? First one is GATE. See, 8 to 10 marks, 8 to 10 marks covered from this subject for ECE branch. Electrical, 6 to 8 marks. Instrumentation, 5 to 7 marks are covered from varieties control systems. See, syllabus is same, but weightage is different because of only one reason. Reason is, check once, communication peoples, ECE peoples have only 8 technical subjects, but electrical peoples are like what more than 8 technical subjects. Automatically sharing will be like what less or not. So that's why weightage is less, but syllabus is common for what? All the branches. Next, ESC, engineering services. Check once, GATE is completely objective oriented exam, but engineering services is what? Objective oriented, at the same time descriptive oriented. So see, for both two cases I considered, see, instrumentation peoples are not allowed for what? Engineering services exam. I think you know it. Engineering services exam is conducted only for 4 branches. One is ECE, EEE, mechanical and civil. For ECE people, see, 12 to 15% of paper covered from control systems. Combination both. That means what? Objective and descriptive overall percentage. Electrical 7 to 9% paper is covered. Are you clear? Next, non-through GATE exams. Check once, non-through GATE exams for ECE 8 to 10%, electrical 6 to 8%, instrumentation also 6 to 8%. Are you clear? And see, state-wise competitive exams also follows almost like what non-through GATE exams. 8 to 10%, 6 to 8 mark percentage, and 6 to 8%. For example, Transco paper is conducted 100 marks. On that, 10 marks, 8 to 10 marks are coming from where it is control system. That is the weightage of control system. Are you clear? So this is the introduction of control system. Further I will show you what is the brief analysis and what is the topic wise explanation. Now I would like to discuss about what are the topics covered in control systems. Topics. Only 6 topics. Topic number 1 is basics. Basics, right? And the topic number 2 is like a BDR and SFG, and like that we have the 6 topics. And before going to discussing about the next topics, there is a beautiful link, and here only I would like to cover what is the overall view of the control systems. So that's why before going to topic number 2, what I would like to discuss in the basics, first I will show you the small screenshot, right? See, generally everyone know about control systems. Why? Because everyone know about the minimum knowledge related to the control systems. In whole control systems is play with only 2 parameters, none other than those are called as what? Poles and zeros, right? Numerator part of the transfer function is generating like what? 0, and the denominator part of the any transfer function is indicating like what? Pole. It's a minimum knowledge and a common knowledge. Everyone know it, right? So my straightforward question is, everyone know it, if pole is lying in the left hand side part of the imaginary axis, the system would be act as like what? Stable. If the same pole is lying in the right hand side part of the imaginary axis, the system would be behaves like what? Unstable. If the same pole is exactly lying on where it is imaginary axis, is behaves like what? Marginally stable. Everyone know it. So stability and instability and marginal stability of the control system is decided by what? Pole position. By default, in the same pole position, if I am given like what? 0, for example, if 0 in the left hand side part of the imaginary axis, then tell me what about the answer? Is it stable or unstable or marginally stable or critically stable or relatively stable or absolutely stable or conditionally stable or asymptotically stable? So there is no answer. Why? What is the reason? Check once my conclusion properly. Both poles and zeros are coming from where it is same origin, but we are given the priority for what? Poles, but we are never given the priority for what? Zeros. Why? What is the reason? So I would like to discuss under where it is basics. Under basics, I would like to cover hardly 10 topics. If you are understanding the 10 topics, no need like what theoretical approachment of what related remaining concepts. Just remaining concepts follow with what? Just shortcut methods, right? So like that, some more concepts also I would like to discuss under basics, like what is the meaning of rise time, what is the meaning of settling time, and what is the meaning of time constant, what is the relation between them, what is the meaning of system, what is the meaning of control system, what is the meaning of open loop control system, what is the meaning of closed loop control system, how to proceed with what theoretically, how to proceed with what practically, each and everything I would like to cover in where it is basics. But on the topics, here I would like to discuss one small topic related to what? Brief analysis. Why? Because if you don't know about this topic, we can't catch related remaining topics, right? So the topic is, everyone know it, gain and transfer function. Gain and transfer function. Now my question is, what is the meaning of gain and what is the meaning of transfer function? And there is any relation between gain and a transfer function? Now I would like to discuss. If you don't know what is the difference between gain and transfer function, you can't catch my next analysis. Not my next analysis, you can't catch next control system analysis. Why? Because complete control system analysis is depends on what? A transfer function. Why? Because that system parameters like a poles and zeros are coming from where it is transfer function, but a transfer function have the link with what? Gain. What is that link? Now I would like to discuss. For example, I consider one rough system, otherwise like what? A plant. For example, this is one rough system. it is a system, and system contains the transfer function or gain of, further we will discuss, wait some time. So this is a system, and it is indicating like input of the system, and it is indicating like output of the system, right? Now what is the general definitions for gain and a transfer function? See the beauty of the subject, both gains and a transfer function have almost same definitions. So first I would like to discuss about the gain definition. The ratio between system output with system input is called as system gain. So this is the general definition, everyone know it. Check once, transfer function also looks like what, almost same, but have small difference. What is the difference? Check once, transfer function also the same ratio. The ratio between system output with system input is called as system transfer function, but here small difference is must and should need to keep Laplace transformation. Laplace transformation of system output with system input is called as system transfer function. General system output with system input is called as what? System gain. My question is, what is the need to what? Keep the Laplace transformation here. That means what is the internal meaning of what Laplace transformation? I think you know it. According to signals and system concepts, otherwise according to signals and system subject, we have 4 type of transform theories. None other than those are Fourier series. Next one is Fourier transformation. Next one is Laplace transformation. Next one is Z transformation. These are the 4 types of transforms. I think everyone know it. But check once, whatever the transform, what is the major aim? The aim is, see these are looks like what, different transforms, but aim is same. The aim is converted from time domain to frequency domain. Converted from time domain to frequency domain. My question is, what is the need to convert it from where it is time domain to frequency domain? Everyone know it. Human communication is completely depends on what? Time domain. System communication is completely depends on what? Frequency domain. If you want to communicate the system, must and should convert it from where to where it is? Time domain to frequency domain. For example, system can understanding the Z transformation, otherwise like what? Z plane analysis. Use what? Z transformation. For example, system can understanding like what? Only S plane analysis. Use what? Laplace transformation. System can understanding only XY analysis. Use what? Either Fourier transformation, otherwise like what? Fourier series. So whatever the transformation, main aim is communicating with what? Systems. So once again I would like to repeat. So please try to remember, complete human communication is analyzed by what? Time domain. Complete system communication is analyzed by frequency domain. If you want to communicate the systems, converted from where to where it is? Time domain to frequency domain. That is the main intention to what? Introducing the Fourier series and Fourier transformation and Laplace transformation and Z transformation relevant to where it is different applications. Okay, leave it. It is a signals and system concept. Now check once. I would like to connect with what? Control systems. See, in my control system analysis, I'm using Laplace transformation. So that means what can you understanding about here? I'm using the Laplace transformation means already transfer function existed in where it is? Frequency domain. So what can you understanding about here? Transfer function existed in only frequency domain. I'm not using any transform theory means gain is existed in where it is? Time domain. I hope you're understood. Are you clear? So what can you understanding about here? Gain is existed in only time domain and a transfer function is existed in where it is? Frequency domain. See, before started this analysis, I clearly explained numerator part of any transfer function is generating what? Poles, is generating zeros and the denominator part of any transfer function, denominator part of any transfer function is generating poles, is generating poles. So listen once, in my whole analysis, wherever I'm using the name like system parameters, in place of system parameters, please replace either pole, otherwise like what? 0. Right? So check once carefully, both poles and zeros are coming from where it is transfer function. That means what can you understanding about here? Poles and zeros, that means system parameters are existed in where it is frequency domain. So these are never existed in where it is time domain. So indirectly here only the clear conclusion, gain never generating the poles and zeros, only transfer function is generating like what? Poles and zeros. Are you clear? So before going to concluding this beautiful topic, one standard and necessary condition is required. What is that condition? Listen once again my statement, check once carefully. Time domain of system output with system input is called as what? System gain. Frequency domain of system output with system input is called as what? System transfer function. But here one small condition is required. What is that condition? Na? See, Laplace transformation of system output with system input, not only the transfer function, here initial conditions must be equal as to 0. Initial conditions must be equal as to 0. I don't want to discuss brief analysis about initial conditions. Why? Because I would like to discuss brief analysis about initial conditions under where it is subtopics related to basics, right? But here just I will give you the small clue related to where it is initial conditions. See, for example, Laplace transformation of derivative function like a dy by dt. Everyone know it. So see, the relevant answer is s into y of s. Check once, whatever the practical system, most probably they were considered only what? S into y of s. But they were neglected remaining terms. What are the remaining terms? Like a y of 0, like a y dash of 0, like a y double dash of 0, and so on. Except s into y of s, remaining all are called as, except s into y of s, remaining all are called as initial conditions. Initial conditions. Initial conditions. Right? Now, my question is, see once, whatever the practical system, most probably Laplace transformation of dy by dt means you are consider only what? S into y of s. Whatever the practical system, most probably Laplace transformation of dy by dt means what? You are consider only what? S into y of s. You are never consider like what? Initial conditions. Why? What is the reason? Where the initial conditions are present, there the noise will be generated. Where the initial conditions forcibly going to like what? 0, there the noise will be like what? 0. So always we required what? Noise-less systems, not like what? Noisy systems. That's why always keep initial conditions are equal to 0. The same logic I utilized here. So what can you understanding about here? If you want to calculate the transfer function, apply frequency domain, but forcibly keep like what? Initial conditions equals to 0. Intentionally, that is indicating like what? Noise-less systems. So what can you understanding about here? Laplace transformation, Fourier transformation, Fourier series, or Z transformation, whatever it is, those are suitable only for what? Noise-less systems, not for what? Noisy systems. And check once whatever the real examples like air conditioners or washing machines or fans or whatever the control systems or traffic lights, whatever it is, those are noise-less systems, not like what? Noisy systems. So see, this is one small analysis. And before going to pack up this analysis, I would like to give the conclusion. The conclusion is, see, here my intention is, what is the meaning of gain, and what is the meaning of transfer function, and what is the relation between them, and what is the difference between them. So it's a straightforward conclusion. See, time domain of the ratio between system output with system input is called as what? Gain. Frequency domain of system output with system input is called as what? transfer function. Those are own definitions. And next one is, see, gain existed in only time domain, but a transfer function existed in only where it is frequency domain. That is the second difference. Transfer function only suitable for what? Generating the system parameters like what? Zeros and poles. Why? Because complete control system is analyzed by what? Those poles and zeros only. So that means what can you understanding about here? Complete control system is locked by what? Only transfer function. Are you clear? Gain is never suitable for what? Generating the poles and zeros. That is the third difference. You have some clarity or not? So initial conditions are like what? Mandatory conditions. Why that mandatory conditions? Briefly we'll discuss later. So whatever it is, okay, leave it. Right? And please try to remember, signals and systems subject is play the key role for EC peoples and WE peoples. Why? Because complete control system is analyzed by Laplace transformation, that is coming from where it is signals and system subject, and complete communication system is locked by what? Fourier transformation, that is coming from where it is same signals and system. Why? What is the reason? See, for example, if you want to calculate the whatever the control system real applications, like a stability, like a steady state error analysis, like a plots analysis, like a state space analysis, there is no doubt need to what? Calculate the pole position. That pole is coming from the transfer function. The transfer function is coming from where it is Laplace domain. Laplace domain is locked by what? Signals and system subject. Like that, check once, whatever the communication system application, that would be depends on what? Bandwidth. That bandwidth is calculated by what? Spectrum. That spectrum is analyzed by what? Fourier transformation. Again, Fourier transformation is coming from where it is signals and system. Once again, I would like to repeat. See, complete control system analysis is depends on what? Pole and their position. That pole is coming from where it is transfer function. The transfer function is locked by what? Laplace transformation. Laplace transformation is coming from where it is signals and system. That is one connection. And see once, complete communication is locked by what? Bandwidth. Bandwidth is coming from where it is analyzed by Fourier transformation. Again, Fourier transformation is coming from where it is signals and system. So if you don't know the signal system analysis, you are not able to what? Easily catch about what? Control system real applications and communication real applications. Whatever it is, one small analysis is finished. So that is the topic number 1. Now my question is, what is the topic number 2? What is the topic number 2? I said you very clearly, there is a beautiful link. What is that link now? See once. For example, I consider one practical system like a fan or a washing machine, otherwise like what? Air conditioner, otherwise like what? Bike systems, otherwise like what? Cars, otherwise like what? Flights, otherwise like what? Washing, that means what? Fighter jets, whatever it is. You consider whatever the real practical control system, it's not a big issue. For example, I consider one practical system. I would like to discuss, otherwise like what? I would like to analyze what is the behavior of the system. Behavior of the system means what? Whether it is working like what? Stable, otherwise like what? Unstable. Whether it is working like what? Marginally stable, otherwise like what? Conditionally stable. Otherwise, whether it is whether it is generating like what? Errors or not. Whatever it is, whatever the real applications, I would like to I want to discuss about that practical control system. Must and should need like what? Pole position. That pole is coming from where it is transfer function. Check once. Topic number 1 is gives what is the theoretical approachment of what? The transfer function. But topic number 1 is not suitable for what? Calculating the practical approachment. Right? Now my question is, how to calculate the practical transfer function for what? Practical system. For example, I have the practical system. My question is, how to calculate the practical transfer function? See, topic 1 is gives what? What is the theoretical approachment? But I want what? Practical approachment. If you want to calculate the practical approachment, need some technique support or not? Those techniques are called as BDR and SFG. BDR and SFG, block diagram representation and signal flow graph. These two techniques are used for what? Calculating the practical transfer function. Right? But these two techniques are work out when initial conditions are equals to 0. when initial conditions are equals to 0. I said you very clearly, initial conditions are equals to 0 means indirectly those are indicating like what? Noiseless systems. Noiseless systems. Noiseless systems. Right? So what can you understanding about here? What I consider the practical system, if it is not generating the noise, that means what? Noiseless system. For example, if I considered, see, BDR and SFG is suitable for what? Calculating the practical transfer function. Once the practical transfer function is existed, practical pole and practical zero in your hand or not? Right? So see, once it's not a big point. By default, what you are consider the practical system, if it is a noisy system, if it is a noiseless system, BDR and SFG is suitable for what? Calculating the transfer function. If it is a noisy system, on that case, BDR and SFG is not suitable for what? Calculating the transfer function. That means, if initial conditions are not equals to 0, it is equals to 0. If it is not equals to 0, on that case, BDR and SFG and Laplace transformation is not suitable for what? Calculating the transfer function. Now my question is, how to handle that case? How to handle that case? It's a very simple. See, once, if initial conditions are not equals to 0, that means noisy systems. If noisy systems are present, for calculating the transfer functions, we are using one beautiful technique. The technique name is called as state space analysis. Right? State space analysis is also used for what? Calculating the same transfer function. So according to my order, see, that is topic number 5. Right? I hope you understood what is the meaning of topic number 2 and topic number 5. My straightforward conclusion is, topic number 2 and topic number 5, the main aim is for calculating the practical transfer function related to what? Practical system. But topic number 2 is suitable for what? Noiseless systems. Topic number 5 is handling what? Noisy systems. That is only the difference. I hope you understood the link. Right? Now my question is, what is the topic number 3? Topic number 3, right? See, there also one beautiful link. Again, come to my story. See, once, first I consider one practical system. Right? Topic number 1 is just a basics, just leave it. See, once, I consider one practical system using either topic number 2 or topic number 5. I'm calculated what? Practical transfer function. Right now, practical transfer function in my hand. Once practical transfer function in my hand, practical pole and practical zero in my hand or not? Once practical pole in your hand, you're able to what? Cross check about that position or not? Once you are cross check about that position, what will you do? You're calculating what? Simply the system behavior like what? Stability or not? So that is my topic number 3. Topic number 3 is none other than, that is called as stability. Right? So this is topic number 3. Right? Come back to my story again. See, once, my whole control systems, I would like to analyze with what? 2 different ways. One is a theoretical approachment, another one is like what? A practical approachment. See my statements properly. Transfer function theoretical statement is what? Laplace transformation of system output with system input is called as what? System transfer function. Their initial conditions are must be equals to 0. That is called as what? A theoretical statement. What is the practical approachment? Either BDR or SFG, otherwise like what? A state space analysis based on the situation. Right? So clear or not? Theoretically and practically. Now come to stability. According to basic knowledge, If pole is lying in the left hand side part of the imaginary axis, that is called as what? Stable. That is a theoretical statement. Now my question is, how to approach the practically? How to approach the practically? See, for approaching the practically, we need some techniques support or not. Those techniques are called as stability techniques. We have the 5 stability techniques. We have the 5 stability techniques, right? So those are RH criteria, Routh-Hurst criteria. Second one is root locus. Third one is Bodo plot. Fourth one is polar plot. Fifth one is Nyquist plot. These 5 techniques are used for what? Calculating the stability. But these 5 techniques are classified by 2 different categories. What are the 2 different categories? Whatever the system, once I mentioned like what 2 different categories means, those are depends on what? Different domains. What are the 2 domains here? Generally we have only 2 domains. One is a time domain, another one is what? Frequency domain. One is a time domain, another one is frequency domain. So please try to remember why, what is the reason. Briefly I would like to discuss when I am discussing like what personal cases. But here just remember, first 2 techniques, that means what? RH criteria and root locus is worked out under only what? Time domain analysis, and remaining techniques like a Bodo plot, polar plot and Nyquist plot are worked out under where it is frequency domain. Why? What is the reason? At the time of my separate topics, we'll discuss briefly. It's not a big issue, right? And please try to remember, these 2 techniques are worked out with the support of what? Time domain parameters. These 3 techniques are worked out with the support of what? Frequency domain parameters. So what are the time domain parameters? Simple: rise time, delay time, settling time, peak time, maximum peak or shoot, steady state error analysis, type of the system, order of the system, K, Kp, Kv, Ka, that means what? Positional error constant, velocity error constant, acceleration error constant, whatever it is, those all are called as what? Time domain parameters. Those time domain parameters are related with what? These 2 techniques. Like that, we have only 4 beautiful frequency domain parameters. What are those? One is what? Gain margin. Next one is phase margin. Next one is gain crossover frequency. Next one is phase crossover frequency. These 4 techniques are called as what? Frequency domain parameters. Those are analyzed by what? These 3 techniques. You have some clarity or not? So what are the time domain parameters? What are the frequency domain parameters? Later we'll discuss briefly at the time of what? My topic number 3. It's not a big issue, right? So this is the just view about what? Topic number 3. Now guess it. What is the topic number 4? Topic number 4. Check once. There is a beautiful link. Up to clearly I connected the link, right? What is the topic number 4? See, once again, come back to my story. See, I consider one practical system. See, using either topic number 2 or topic number 5, I calculated practical transfer function. Once practical transfer function is in my hand, practical pole is in my hand. Once practical pole is in my hand, I'm able to what? Analyzing the system behavior like what? Stability. For analyzing the practical stability, I'm using the topic number 3, like a RH criteria, root locus, Bodo plot, polar plot, Nyquist plot. I'm using one of the technique. While using any one of the technique here, I'm calculating like what? Stability. See, once I'm calculating the stability, if the result is like what? Stable, it's not a big issue. Why? Because always we required like what? Stable responses. By default, if the result is like what? Unstable, again we need to what? Convert into where it is stabilization or not. I hope you understood. See, once using any one of the technique, I'm observing the system behavior. If the result is like what? Stable, it's not a big issue. Why? Because always we required like what? Stable responses only. By default, if the result is like what? Unstable, again we need to what? Convert into where it is stabilization or not, right? So for converting instability to stability, need one some technique or not? That technique is called as what? Topic number 4. None other than that is called as what? Controllers and compensators, right? So topic number 4 is controllers and compensators. compensators, right? That means what? P controller, proportional controller, I controller, integral controller, D controller, derivative controller, PI controller, PD controller, PID controller, lead compensator, lag compensator, lead lag compensator, lag lead compensator. See, what I discussed all these techniques, whatever the technique, the major aim is what? Converted from where to where it is? Unstabilization to stabilization. By default, if any practical system losing the stability, again the stability is gained by what? Using these techniques. Right? So that is the importance of what? Topic number 4. See, once again I would like to conclude. Topic number 4, main aim is whatever the controller, whatever the compensator, the main aim is converted from where to where it is? Unstabilization to stabilization. Right? So see once, these 5 topics common for electronics and electrical and instrumentation. But last topic only for EE electrical people. Topic number 6. Topic number 6 only for electrical. Only for electrical. Sometimes instrumentation 2 years before, right? Topic number 6. Right. What is the topic number 6? See once, I mentioned very clearly this is what? Related to electrical subject. By default, if any electrical system is present, otherwise like what? Mechanical system is present. I think you know it. What are the electrical networks? What are the mechanical systems? By default, if any electrical network, otherwise like what? Mechanical system is present, how to calculate the transfer function? That is a topic number 6. So topic number 6 is modeling. Topic number 6 is modeling. Modeling. Remember, modeling intention also like what? Calculating the same view. That is what? Transfer function like a BDR and SFG and a state space analysis. Modeling topic internal meaning is calculating the transfer function for what? Electrical systems and mechanical systems. For general systems, BDR and SFG and state space analysis is handled to what? Calculating the transfer function. For electrical systems and mechanical systems, the same transfer function is handled by what? Modeling. Are you clear? So these are the topics, right? So lesson once. See, in these 6 topics, gate point of view, otherwise engineering services point of view, whatever it is, heart of the control system is topic number 3. Heart of the control system is topic number 3. Why? Because 4 to 5 marks are coming from this area only, right? Next, 1 to 2 marks are coming from this area, and controllers and compensator also like what? Same, 1 to 2 marks. State space analysis 2 to 3 marks, and basics also like what? 1 to 2 marks. 1 to 2 marks. Topic number 6 is may or may not be questions are coming from this area, like a microprocessor in where it is digital, and like a DSP in where it is signals and system, like a VLSI in where it is analog electronics. So check once, VLSI is the subportion from where it is analog electronics, and microprocessor is the subportion from where it is digital, and DSP is the subportion from where it is signals and system. So those subportions may or may not be questions are coming from that area. If by default one question is coming from that area, damn sure that is what? 2 marks validity. Like that this same here also modeling. If question is coming from this area, most probably 2 marks, otherwise like what? Unconsiderable concept, that is